So we believe that the universe is expanding, and we're going to explain why we think the universe is expanding. Okay, and the main reason is because of the Doppler effect, which is what we talked about in our last video. Right? So sound and light travel as waves. Right? The distance between the waves is our wavelength. And we talked about how if you have a higher wavelength, you have a lower frequency. And when objects are moving, you create this Doppler effect. Okay, so let's say we have a point. Let's just pick a random point in the universe. Okay, and let's say it's giving off, maybe it's a sun, it's giving off light. Okay, so the center of the point, or where it originates, let's give it a circle and make sure the circle is at the center. And similar to the tuning fork in the previous video, let's say, whoa, that's way too big. Let's get that back there. All right, let's say the object is moving. Let's just do this for the future. All right, so if the object starts moving, then you remember our light or sound is going to be extrapolated differently to where now the center is here and it moves. Oh, it moves again. Let's put that in the center. And one more time. Nope. My circles are too bad to be recognized right now. That's not a circle. All right, there we go. All right, so we talked about how the Doppler effect, if you're standing on one side, the frequency is going to be higher. So if we look at this again, if an object is coming towards you, like let's say we're right here, pretend these are sound waves, we have low wavelengths and high frequency, right? So we can tell if an object is coming towards us or coming away from us based off of the pitch of the sound, right? Remember that NASCAR or cars driving by, it has that meow, where it starts off high and then it goes meow, and it gets low, right? For this object, instead of sound and pitches, we have light, and light is determined by how great the wavelengths are. So if we take a look at that, we have our spectrum of light up top, of visible light. So our lowest wavelength, which is purple, and our color that has the highest wavelength is red. Right? So if you see red light, that means you see the longest wavelength that is visible to our eyes. If you see purple, like a purple neon light, that's giving off the lowest wavelength. So let's say we are on Earth, which we are, and we have all of these distant suns and solar systems and galaxies, and they all give off light. Well, it turns out that the light we see from these planets are red. Okay, so what could that mean if we are getting red light? So again, let's go back to our sound points here. So this is a low wavelength, high frequency. This is what you would see if it's coming towards you, right? If we're standing here. Let's be it to you, coming towards you, right? So this would actually be, if the planets or galaxies were moving towards us, this would be purple, right? Because it's a low wavelength. But it turns out that the colors that we see are actually red. Because if you remember, our wavelength on the right side, or as they're moving away from us, are going to be greater over here. Right, so we have high wavelength, low frequency. So instead of sound, we have color, and in this case, we have red light, right? So red light means something is moving away from us. Purple light means that it is coming towards us, okay? Again, that's a Doppler effect. So scientists are able to tell that that galaxies are giving off red light, meaning things are moving away from us, which is evidence and substantial evidence that points out that our universe is expanding.